Hello, in this lecture, we are going to discuss Laplace transforms. It is not, it is, it is worth mentioning that Laplace transform will find many such applications as we go along in various fields in physics itself, and it forms an important portion of your examination also. So, without further wasting time, let us start. Okay. So how does a transform theory helps us? That is the first thing that one needs to understand. At times you'll find that there are some issues regarding solving of the differential equations, and they may be made easy by the help of the transform theory. Okay. So what does really Laplace transform do, or in general, what does transform do? Is so it basically changes your space. Okay. For example, if you are solving a differential equation, let's say any initial value problem or a boundary value problem, what Laplace transform does, or what in general transform does, it reduces it to in a problem in a space where you have an algebraic solution to it. So here you have an algebraic solution, or you can say it transforms it to an algebraic sort of equation. And when you take the Laplace inverse of it, you again get back the solution for it. Okay, so whenever you try to solve an initial value problem, one of the ways can be to go through transform theory. Okay, and it may be applicable to both ordinary differential equations as well as partial differential equations. So if you are served with an initial value problem or a boundary value problem regarding ordinary differential equation or partial differential equation, one way can be to make use the Laplace transform. By using a Laplace transform, this particular differential equation reduces into an algebraic sort of equation, you can say, or algebraic problem, you can say. And in order to extract back the solution, what you can take a Laplace inverse. And once you take the Laplace inverse, you will get back the solution. So one of the ways in which you can easily solve these things is to take a transform. Okay, where you will find it very quite often. You will find them in the cases where you have certain forcing functions. So what do I mean by forcing function? Let's say what I want to say is here it is like, for example, you are supplied with the ordinary differential equations, ordinary differential equation or a partial, let's say ordinary differential equation for right now, an nth order linear differential equation or nth order linear differential equation, let's say LF of t, and it is equal to some g of t, and you have this driving term or inhomogeneous term. So this driving term or inhomogeneous term contains some Dirac delta kind of thing, okay, or probably has some discontinuities. Okay, some discontinuities, like a unit step function is given on that side. So one convenient way to solve such problems can be one convenient way to solve this problem can be to use the Laplace transform. Right now, then we'll go along and see how does Fourier transform does the same thing. Okay, so one way is to use Laplace transform. So wherever you'll find that your driving forces has certain discontinuities, or you have a source function in the case of your inhomogeneous term, or a Dirac delta function being accompanied in the driving term, or probably sort of impulsive force, that is, it acts in a very short interval of time. For example, if you have here a force term which acts in a very small interval of time, or you can say a impulsive force, then you can think of something called as Laplace transform. So one of the ways where you will find that Laplace transform becomes indispensable is wherever you are solving these initial value problems or boundary value problems. One of the ways can be to take a Laplace transform. This Laplace transform reduces this particular initial value problem or a boundary value problem into an algebraic problem. And what you can do, you can take a Laplace inverse and get back the solution. Okay. Specifically, more importantly, you will find that these Laplace transform will be very useful to you if the driving terms contain some discontinuities, or probably an impulsive force, or you can say a source term. In such a problem, you'll find that Laplace transform will be quite indispensable too. Now, let us first focus our attention to the definition. So I'm saying let ft be a function. Let ft be a function for all t greater than equal to 0. For all t greater than equal to 0, the Laplace transform that I'm going to write this way of function ft is defined as integration from 0 to infinity e to power minus st ft. Okay, so this is what is known as your Laplace transform. And eventually, see here, your integration is going all along on t. and when you place from 0 to infinity, so your t will not be there. So it will remain after all a function of s only. So a Laplace transform is a function of s, and it is given by e to power minus ft. Like for a small function ft, if I'm taking the Laplace transform, then it is equal to this integral. And the convergence of this integral is essential. The condition is that this convergence of integral should be ensured. Ensured. Okay, and this particular term is called as a Laplace transform operator. Let's say this corresponds to your okay, and you'll find that generally this Laplace transform generally this will exist for more than one values of s. And that this is something that we are going to see further. There, you can also see that there is also one-to-one correspondence between the ft and the Laplace transform. There exists a one-to-one correspondence between the function and the Laplace transform. Okay, one needs to understand that this Laplace transform will, like this particular integral will only converge if it meets following conditions. The first condition to it is that function should be of exponential order. Function ft must be of exponential order. Function ft must be of exponential order. That is, when I say that my function is of exponential order, that implies your ft ka mod can be written less than m e ki power some alpha t or at, where m and a are some positive constant. Okay. So if I can write in this fashion that my function ft ka mod is less than equal to capital M e ki power at, then the function ft is of exponential order. And if your function is of exponential order, then your integral, this particular integral would converge. So this is the first prima facie thing that one needs to see, that if your function ft is of exponential order, then your Laplace transform would exist. Laplace transform would exist in that particular case. For example, let us say, let us take one example. Let us say t, ft is equal to t. So if function ft is equal to t is there, then one can clearly see that your function ft is this, ft is equal to t is this, and your e ki power t, how does e ki power t behave? This behaves this way. So in any case, you can see that your e ki power t is greater than t for all t greater than 0. Or in other words, I can say that even if I take a mod of it, because for a positive quantity, whether you take a mod or whether you don't write a mod, it is one and the same thing, but I want to fix it in this format. It is less than e ki power t. Okay, so clearly a function ft mod can be written less than m e ki power at. So your t mod can be written less than m e ki power at, where m is equal to 1, a is equal to 1. So you can see that your ft is equal to t is of exponential order. Is that fine? So your function ft is equal to t is of exponential order. Is that fine?
Yes, sir.
Okay, good enough. So, okay. Or for example, let us take another example. How do you think about ft is equal to e ki power t square? This is not of exponential order. This is not of exponential order. Why this is not of exponential order? Clearly, you can see that you can never write e ki power t squared less than any m e ki power at. Why? Because as t is large, as t is large, as t is made large, t square would be way too greater than t, and e ki power t square would be way too greater than e ki power t. So for large t, you can never write that your e ki power t square is anything. You cannot write this expression. You cannot write this expression. Are you getting my point? So for a function to be of exponential order, you should have this kind of inequality for some t greater than, let's say, t. So I should write somewhere. If I've missed it, there should exist some t greater than capital T. Some t greater than capital T होना चाहिए such that ft का mod is less than equal to m e की power t. So there should be some t greater than 0, such that for all t greater than t, your ft ka mod can be written as less than m e की power t. So here, in this ft is equal to t, your capital T you can take as 0, because for all t greater than 0, you can see that your ft is equal to t is less than e की power t. So your e की power t is rising above ft. So in any case, you can write that. Is that clear? So this particular function e की power t square cannot be of exponential order. Why? Because we can never write e की power t square less than some m e की power t. Because any day, if this is t square, you see, you write 10 e की power 12. You take t equal to 10 की power 12. So what e की power t would be? You write any sort of term. I'm not bothered about it. So in any case, this will be e की power 10 की power 12. Is that clear? But here you see, here it will be e की power 10 की power 20. Here it will be e की power 10 की power 24. So in any case, for large t, one can see that e की power t square would dominate e की power t. So here you have a linear power over e, and here you have a quadratic power of t over e. So you can never write this way for very large t, because for very large t, this will always be the case. And this will any day contradict this thing. So you find me some t where this is true, then I'll find you a t greater than that, and I'll prove that for all these t, your assertion is false. Okay. So for example, Bharat says, no, I'll do one thing. I'll take a is equal to 10 की power 12 here. So it will be 10 की power 12 into 10 की power 12, 10 की power 24. So I'll say, okay, you take this. I'll take t equal to 10 की power 36. Now what? So in any case, for larger t, you will find that this is going to dominate. This is going to dominate. Any day, this is going to dominate. So e की power t square, the rate of growth is way too greater than e की power t. So for some t, you may find that, okay, fine. But for larger t, again, you'll find that e की power t square would start dominating. The assertion is that you have to write your ft ka mod less than equal to m e की power at for all t greater than some t. So if I find some t such that ft ka mod is less than equal to m e की power t for all t greater than this capital T, then I will say that my function is of exponential. ऐसा नहीं हो सकता कि यार here you can say that, okay, I've taken a is equal to this, then what? I'll say take t equal to 10 की power 36, then what? So for those things, your assertion will again become false. So one has to understand this thing. Is that clear? Is that clear? आया ना तो बोलो यार. Is that clear? Okay, good. So this is one thing that needs to understand. And second condition is that your function ft must be piecewise continuous. Must. And when I say piecewise continuous, for example, if I say that my function ft is piecewise continuous, that implies let us divide it into subintervals. Let us divide my function into subintervals. And on all of these subintervals, my function is sectionally continuous. Okay, all these definitions, whatever are written here, these are all continuous. So such functions are called as piecewise continuous function. Such functions are called as piecewise continuous function. So one has to remember two things, that for existence of your Laplace transform, the sufficient conditions are one, that is my function ft must be piecewise continuous. And secondly, my function ft must be of exponential order. If these two conditions are met, then I can define the Laplace transform. Laplace transform. Let us start with the Laplace transforms of some elementary functions. some elementary functions. The first example that happens is e to the power 80. Okay. Okay, one needs to find what would the Laplace transform of this particular functions. One can say e to the power minus st, e to the power 80 from 0 to infinity. This will be the Laplace transform of e to the power 80, isn't it? And how to write? It will be 0 to infinity e to the power a minus s t dt, and this will be e to the power minus a minus st upon a minus s from 0 to infinity. And one can clearly see that this particular integral would diverge if a is greater than s. So if a is greater than s, or if s is greater than a, sorry, s is less than a. If s is less than a, then this term would remain positive. And if this terms remain positive, if we place infinity as the upper limit, then this particular thing would diverge. So what is the condition for existence of or convergence of this particular integral? The condition should be that your s must be greater than a, and in that particular case, your Laplace transform would be s minus a. Always remember that this particular thing usually children forget. Don't forget the condition for the existence of Laplace transform. And it is very easy to see. It is no big science. You can just integrate it and you will be able to find it. Is that clear? Okay, good enough. Chalo ji. Now, second case, let us take another case. For example, if I want to find the Laplace transform of 1, so all I need to write is that just place a equal to 0 here. So e to the power 80, just place a equal to 0, this will be 1. And if you place a equal to 0, your Laplace transform of 1 would turn out to be 1 upon s. It is as simple as that. Okay, so Laplace transform of 1 is s, and then you have this. Third, you can say what would be the Laplace transform of cos 80. So how to write the Laplace transform of cos 80? So it is equivalent to writing 0 to infinity e to the power of minus st e to the power, cos 80. Isn't it? And in the theory of differential equation, we have studied that 1 upon d, this particular thing represents our what you can say, represents the integration. 1 upon d, this particular linear, d represents your derivative, 1 upon d represents your integral. So this is something that I can write. And from shifting property, I know if I shift my e to the power minus st here, so there will be d minus of s here. And cos 80. And what we had to do whenever we had to solve this particular thing, we had to replace instead of d square your minus of a square. This is what we do. So I'll do one thing, e to the power minus st, I'll multiply with d plus s and then d minus s. So this will become d square minus a square cos 80. So I'm doing an integration here. So what will happen after all? So instead of d square, you have to replace a square. So it will become minus 1 upon a square plus s square e to the power minus st. And then what will be d plus s? D plus s, derivative of cos is a sine 80 with a negative sign here, and then plus s cos 80. This is a negative sign here. And eventually, I will write that this particular integration, that is integration e to the power minus st cos 80 will be equal to 1 upon s square plus a square e to the power minus st. And then you have this a sine 80 minus s cos 80 from 0 to infinity. Is that fine? Now again, the same case that if s is greater than 0, if s is greater than 0, only then their integral would exist. If s is less than 0, then this particular integration would go towards infinity. Because you see, whatever be the case, this is after all sine and cosines, these are all periodic and bounded functions. So you cannot make any assertion from here. You can only say that this will be some bounded kind of thing. Okay, this will form a bounded this will form a bounded function of t. But rather, if you see that if you write s less than 0, then this particular infinity, when placed here, a bounded function multiplied by infinity would give you an infinity any day. So you have to understand that this particular Laplace transform, this integral would not diverge only if s is greater than 0. And only if s is greater than 0, the upper limit e to the power minus st would drive this particular entire term towards 0 only. And if you place s equal to 0 here, so what you will get? You will simply get, I think, if you place s equal to 0, if you place t equal to 0, sorry, second case, infinity place kiya aapne, sorry, these are the limits for t. So if s is greater than 0, and if I place at t infinity, this will become 0. And if I place 0 here, so what it will become? This will become, I think, 0. And there is a negative negative, so this will become s upon s square plus a square. Is that fine?
हाँ
Yes
भैया,
or is that fine?
ये कंडीशन हमेशा चेक करनी पड़ती है कि आप डायरेक्ट फॉर्मूला अप्लाई नहीं कर सकते हम?
नहीं, तुम डायरेक्ट फॉर्मूला अप्लाई करते थे पहले भी, बट यू नेवर यूज्ड टू पे हीड टू दिस. This is every time if you see any book, everywhere this condition is written. Why I'm saying this is probably in exam one may ask you that what if it what if what is the condition for existence of a Laplace transform? So if you remember, this will be a good thing for your examination. Otherwise, हाँ ठीक है, formula wise I know that this is s upon s square plus a square. But if examiner writes somewhere s less than 0, and then there will be a problem if one asks what is the existence for condition for this thing. Are you getting my point or not getting my point?
Yes, okay.
है ना, मतलब ये लिखी हमेशा रहती थी, हमारा ध्यान नहीं जाता. I hope it is clear now.
हाँ भैया, got it.
Okay, good. चलो जी. चलो. Now, what would be Laplace transform not deriving it? I think this is quite clear. So, ये हम same यही steps लगा लेना, and you'll find that. ठीक है. Okay. Now, there would be some reduction formula usage, and I hope that you'll find that those things in your book. If it is Laplace transform of t की power n, then it is a long derivation, so I'm not much bothered about it. So if I write for all n belongs to natural number, this will be equals to what? This will be equals to, just give me a minute, huh? This will be equal to n factorial upon s की power of n plus 1. And this also exists for all s greater than 0. Okay, let me derive it so that you understand कि इसका derivation कैसे होता है. So देखिए. Okay, so how to go about it? So what I'll do, I'll write this particular integral as in. What is your in? E की power minus st t की power n dt. Is that fine? Now, in this particular thing, you can take this as your integrable term, this as your derivative term, whatever you say, I late or something. So whenever you do an integral by parts, one has to understand that one part will be easily integrable and one part would be easily differentiable. So one has to see that if I try to integrate this particular stuff, it is going to increase. The powers are going to increase, and this particular term is quite innocuous or like very harmless term. So you can integrate this term, and this you can take this term as a derivative. So what I'll do, I'll write in is equal to integral of this. This will be t की power n divided by minus s e की power minus st. Is that fine? And this is from 0 to infinity. And then minus integration of this term will give you 1 upon s. So I write 1 upon s here. And this particular term derivative will give you in t की power n minus 1, right? And then you will have this e की power of minus st, and then you will have a dt. So you will have a 0 to infinity, and this is how it is. Now, so one can clearly see that your in happens to be n upon s in minus 1. If you see this term would be what? This will be in minus 1, isn't it? So I'm controlling my integral index by the parameter n. So here, if the index is like here, if the exponent is n, then index of the integral would be in. Here the integral, here the index exponent of t is n minus 1. So your index of integral would be in minus. Is that fine? Similarly, if you go along with in minus 1, what will happen? It will be t की power n minus 1 divided by minus s e की power minus st from 0 to infinity. And why I have forgotten this term, you can clearly see that for all s greater than 0, this particular term would go to 0. Always remember, whenever there is a polynomial term and an exponential term, and one asks limit x tends to infinity, this will always be 0. Your exponential's rate of growth is way too greater than any polynomial rate of growth. So for example, here if you write t की power n, and if you put this e की power st in the denominator side, so this will be this kind of format, and one you can remember this as it is. So for any nth order polynomial, this would be the case. And if you want to solve it, you can do it using simple L'Hospital rule. Take it as a any polynomial of degree n, try to differentiate it n times, you will get n factorial upon e की power x, and this particular limit you will get 0 any day. And if you place 0, so your t at t equal to 0, this will be 0. So this particular term will any day vanish. So now I'm coming to this particular term. This will be equals to n minus 1 divided by s, and this will be in minus 2. So what you are getting that your in is equal to n by s in minus 1. Your in minus 1 is simply n minus 1 into s in minus 2. Similarly, your in minus 2 would be what? It will be equals to n minus 1, n minus 2 divided by s in minus 3, and so on and so forth. Is that clear? And last term would be some I1 would have been written here, I2 would have been written here. Is that clear or not clear? ये चीज समझ में आ रही है कि मैं बोले जा रहा हूँ कुछ भी?
यस सर।
ओके, गुड इनफ। ठीक है, तो यहाँ पर देखो, यहाँ पर क्या n माइनस 2 और यहाँ पर क्या रहा है n माइनस 3। सो यहाँ पर आ रहा है n माइनस, यहाँ पे क्या रहा है I2। I2 मतलब क्या रहा होगा n माइनस n-2, राइट। और I1 का मतलब क्या रहा होगा n माइनस n-। इज दैट क्लियर? इवेंचुअली जो यहाँ पर है वो यही तो लिखा जा रहा है 2। इवन इफ यू डोंट कंसिडर ऑल दीज थिंग्स, यू कैन सी दैट दिस इंडेक्स इज कमिंग हियर, this index is coming here, this index is coming here. So I can write that my in is equal to n by s into in minus 1. In minus 1 you can write n minus 1 upon s into in minus 2. In minus 2 you can write n minus 2 upon s, so on and so forth. And last term would be 2 upon s. And then again you have to take a Laplace transform of t power 0. That is not here, because if you write here I1, then it will become I0. Okay, so instead of I0, I'm writing Laplace transform of one of these. Is that clear or not clear? क्योंकि इसके आगे क्या आएगा, इसके आगे I1 के बाद क्या आएगा, I0 ही तो आएगा। I0 के लिए मैं क्या लिखूं, उसको I minus 1 तो नहीं लिख सकता ना, सो मैं इसको I0 को सिंपली लिख रहा हूँ Laplace transform of t की पावर 0. Is that fine?
Yes sir.
Recursively, because okay, now you see that your in, how many n's are, how many terms are here, how many terms are here. So what you will find that यहाँ पर कितने terms रह गए. So I started with like, so there are n कितने terms होंगे 2 से लेकर n. एक कोई गलती हो रही है, चेक करो। एक कोई गलती कर रहे हम लोग। in is this n upon s in minus 1, fine, ठीक है। in is this लास्ट टर्म क्या होगा I0, एक चेक करते हैं इसको, कुछ तो गलती कर रहे हैं। व्हाट वुड बी I1, सॉरी इसके भी आगे एक टर्म होगा, दैट वुड बी I1। I1 वुड बी व्हाट 1 upon s into I0, और I0 के आगे कोई टर्म नहीं आएगा, I0 की जगह हम रुक जाएंगे, राइट। सो देयर वुड बी 1 upon s here. इज दैट फाइन? सी I2 तक तो आ गए थे, I2 के आगे एक I1 भी तो होगा। रिकर्जन है, इसी को रिकर्जन कहते हैं। आप क्या कह रहे हो, in के अंदर कौन आ गया, in minus 1, in minus 1 में कौन आ गया, in minus 2, in minus 2 में कौन आ गया, in minus 3, in minus 4 में क्या आएगा, in minus 4 would be n minus 3 upon s into in minus 4. ऐसे चलते जाओगे तो एक बार I2 भी तो आएगा। What would be I2? I2 would be 2 by s I1, and what would be I1? I1 would be 1 upon s into I0, and this I0 के आगे नहीं जा सकता। क्यों नहीं जा सकता? Because then there would be some constant I minus 1, and this is not acceptable. So what I'll do, I0 को I will write Laplace transform of t की पावर 0. Is that clear? अब मुझे होता है यहाँ से लेकर यहाँ तक कितने टर्म्स हैं, how many terms are from here to here, जो मैंने ये बताया। So you can clearly see there are n terms, 1 2 3 4 5 6 से लेकर n तक है। Is that clear? So I'll write this as n factorial, and I'll divide it by s की power n, and then Laplace transform of t की power 0. What is Laplace transform of t की power 0? Laplace transform of 1, that is 1 upon s. So answer would be in would be equals to n factorial divided by s की power of s. And this is true only if s is greater. Is that clear or not clear?
हाँ भैया।
Good enough. Now try to find me a Laplace transform. Let us start with a few questions. Okay, and similarly a few more formula I'm going to write. What would be sine hyperbolic 80? So sine hyperbolic 80 you can express in terms of linear combinations of exponential terms. So you will get this term, a upon s square minus a square, provided s is greater than modulus of a, a Laplace transform of cos hyperbolic at. I'm leaving it to you as a homework. Please try to do this. Otherwise, I will have to derive. These are very चलो मैं करी एक part करी. Let us try to do this thing. ठीक है जैसे कि if I've derived each of these terms, then why not this? So what would be Laplace transform of sine hyperbolic t? It will be equals to Laplace transform of e की power of I think 80 and minus e की power minus 80 divided by. This is how you define your sine hyperbolic. So your answer would be e की power, your integral would be e की power minus st, e की power 80 minus e की power minus 80, and you have a 1/2 here and you have a dt here. So eventually, what you will find that you will get this thing as 1/2 integration from 0 to infinity. This is e की power a minus st, and then minus e की power of minus a plus s dt. Is that clear? And what is this? This is equal to, I would say this is equal to writing a Laplace transform of e की power of 80 here, and this is minus writing Laplace transform of e की power minus 80 here. Isn't it? And this would be 1 upon s minus a, and this is minus 1 upon s plus a. And 1/2 will follow, obviously. And this is true only if this particular term is true only if s is greater than a, and this particular term is true only if s is greater than minus. Okay, so I'll write s is greater than modulus of a. If a is positive, then this will be true. If a is negative, then this will be true. Is that clear? So for all s greater than modulus of a, your Laplace transform of sine hyperbolic t can be defined, and this would be equals to, I think, writing a upon s square minus a square. And on the similar lines, you can find the Laplace transform of cos hyperbolic t. And this is also true for all s greater than modulus of a. Is that clear?
हाँ भैया.
Yes.
Okay. Chalo ji. Try to find one question so that that will give you some sort of. So I'm writing cos Laplace transform of cos 2t can be represented by which of the following graphs? Oh, अच्छा एक मतलब t greater than 0 के लिए मान लो से ठीक है वैसे पता लग गया ऑप्शन नहीं मैंने बनाया ऐसे ठीक है दिस इज 1 दिस इज 2 this is 3 and let's say this is your option number so this is a question for you try to do it.
सर ए ऑप्शन।
राइट ये ऑप्शन। ठीक है, तो कैसे करें? सो लेट अस सी द Laplace transform. So Laplace transform of cos 2t क्या था? cos pt क्या दिया था? cos 2t दिया था, राइट? So it is equivalent to writing what? It is equivalent to writing 1 upon sorry 2 upon या फिर s upon s square plus 4, right? Now you see as s tends to infinity, this must tend towards 0 only. So इसको थोड़ा सा आगे तक लेके जाएंगे तो ये ऐसे दिस इज ऑफ सो अभी अपन को ग्राफ बनाना है, ठीक है? सो लेट अस मेक अ ग्राफ। पहली बात ने क्या सिखाई थी ग्राफ बनाने में? ऑलवेज सो यू हैव टू मेक अ ग्राफ ऑफ s versus fs, right? So at s equal to 0 you have a 0, as s equal to 0 you have a 0, as s tends to infinity you again have a 0, so it is tending towards 0. Is that fine? Now try to take the derivative part of it. So f dash s would be equals to what here? F dash s would be 1 upon s square plus 4 minus 2s square plus 4 का whole square. So you'll have a I think 4 minus of 4 का whole square. Is that clear? And f dash s would be greater than 0 only if your 4 minus s square is greater than 0, or you can say that your s lies between minus 2 and plus 2. However, we are only considering from 0 to 2. From 0 to 2 your function would be increasing, and then your function would be decreasing in such a manner that tends to infinity is going to go towards 0. So this is how your graph of s upon s square plus 4 would look like. Is that clear? हम थोड़ा सा ढंग से बनाया नहीं, otherwise this is better. Is that clear? इसको और थोड़ा better कर सकते हो when you are going to plot it somewhere, but most approximately this would be the graph. Okay, and if you want to really see that whether this would be the case or if this is the case, one has to see the second derivative. And second derivative will be quite complicated thing to see here. Okay, complicated as in you can do it, but again, this is a difficult thing. Only a particular idea of graph would do. Is that clear?
यस सर एफ ये 4 माइनस एस स्क्वायर आपने ग्रेटर देन 0 क्यों लिया?
जिससे कि ये पता चले कि मेरा फंक्शन इंक्रीजिंग का है, फंक्शन डिक्रीजिंग का। So if your function f is defined on interval I to r, and if f dash x and if function is increasing, then f dash x must be greater than equal to 0 for all x belongs to 5. Okay, so for a function to be increasing, this is how you judge your function, right?
ओके सर।
Okay, so और अगर लेस देन लिख दोगे तो तुम्हें डिक्रीजिंग का पता लग जाएगा। तो वो तो है भी, अगर मान लो फंक्शन इंक्रीज करेगा और इन्फिनिटी में उसको 0 पे आना, तो ऑब्वियसली इट हैज टू डिक्रीज, because if it is going to increase forever, then how would it asymptotically touch the x-axis as s tends to infinity? Is that clear now?
हाँ भैया।
Okay, good enough. Chalo ji. Now let us focus our attention to important two theorems, and then we'll finish things in the next class. Let me write it first, and then I'll see. This is called as first shifting theorem. This is called as first shifting theorem. So if I have a function inside ft, if I write my function gt is equal to e की power at into ft, and let's say my Laplace transform of ft is defined as f of s. Okay, by this particular thing, that is Laplace transform is already defined. That is, it is equals to capital F of s. Then what I can do, or I can say that my Laplace transform of f of t is what? It is equals to integration 0 to t ft e की power minus st. You know, then what I have to do, I will simply replace what I can do. I should simply replace my s, my s by simply, what should I say? S minus of a. I should simply replace s by s minus a. If I do so, what I'll get? I'll simply get f of s minus a is equal to integration from 0 to infinity ft e की power of this is, I think मैंने कुछ गलती तो नहीं कर दी ना? So instead if I replace it by s minus a, तो यहाँ पर क्या आएगा? S minus a. Is that clear? And this will be 0 to infinity. इस नेगेटिव को कॉमन लेके बाहर कर दिया e की पावर at ft e की power minus st dt. Or in other words, if I want to write this as, so f of s minus a is equal to writing 0 to infinity e की power minus st of e की power at ft dt. Is that clear? And it is what? It is equal to g of t. So after all, what I found is that if I multiply my function by e की power at, and this Laplace transform, the Laplace transform of f is fs, then the Laplace transform of this particular thing will be f of s minus. Is that clear?
Yes, sir.
Okay, so this is called as first shifting theorem. This is called as first shifting theorem. And remember that ये function, ठीक है, remember that जब हम लोग है ना एक्सपोनेंशियल का कर रहे थे या फिर एक्सपोनेंशियल कर रहे थे तो हम क्या कर रहे थे, s ग्रेटर देन e लिख रहे थे, s ग्रेटर देन e लिख रहे थे कि नहीं लिख रहे थे? चलो मैं समझाता हूँ मैं क्या करने की कोशिश कर रहा हूँ। देखो यहाँ तक क्लियर है। सो ये पहली चीज तो समझो, इफ योर फंक्शन एफ टी, द लैप्लस ट्रांसफॉर्म ऑफ फंक्शन एफ टी is equals to what? F of s, and instead of f of t, if I'm trying to write e की power at into f of t, then the Laplace transform would be replaced by f of s minus of a. Is that fine? ठीक है, this is what you call as a first shifting theorem. I'll write here, this is what you call as a first shifting theorem. So basically here you are shifting on the s axis. मतलब जो Laplace transform पे जो ग्राफ बनेगा वहां पे फंक्शन कहाँ पे शिफ्ट हो जाएगा, instead of s it will be s minus. So therefore the name first shifting theorem. And meanwhile I'll meet you in the next session. You just try to find this integration, this Laplace transform. Try to find the Laplace transform of e की power at into cos pt, okay, t की power n into e की. So try to find this is your question number 1, and this is your question. Try to do this, and I'll join in with the next meeting.